Hello everyone. In this video, we will study the I/O interfacing of microprocessor. Now let us try to understand the basic interfacing concept. An I/O device can be interfaced with the 8085 microprocessor either as a peripheral I/O or as a memory mapped I/O. The main objective of interfacing an output device is to get the information or a result out of the processor and to store it or display it. Peripheral mapped I/O. Now there are two types of I/O techniques, peripheral mapped and memory mapped. The first one is peripheral mapped. In peripheral mapped I/O, the instructions in and out are used for data transfer and the device is identified using 8-bit address. The instruction in inputs data from an input device such as keyboard into accumulator, and the out instruction is used to send the contents of the accumulator to the output device such as LED display or 7-segment display. The microprocessor 8085 can communicate with 256 different output ports with device ranging from 00H to FFH. Generally, 2-byte instructions are used in peripheral mapped I/O. And those instructions are in port address. This is a 2-byte instruction which transfers data from port address to the accumulator. Output address. This instruction transfers the data from accumulator to the output device. Memory mapped I/O. In memory mapped I/O, the memory related instructions are used for data transfer and the device is identified by a 16-bit address. The microprocessor communicates with an I/O device as if it was one of the memory locations. Generally, 2 3-byte instructions are used in memory mapped I/O instructions, such as, and those two instructions are LDA port address and STA port address. LDA port address is a 3-byte instruction which copies the data of a given memory location into accumulator. It copies, and STA port address copies the content of accumulator into memory location. Now there is one catch. In memory mapped I/O, though we are talking about accumulator, but here the transfer takes place from the I/O device or from the port to the registers, not accumulators. Now we'll try to differentiate between peripheral mapped I/O and memory mapped I/O. Peripheral mapped I/O consists of 8-bit address to connect to any device, and memory consists of 16-bit address. In peripheral map, 256 I/O devices can be connected. In memory map, 65536 I/O devices can be connected, which is ideally not possible, practically not possible. Instructions in peripheral mapped I/O are 8-bit port address, and in that 16-bit. The in and out instructions are 2-byte instructions. Here the load and store instructions are 16-byte instructions. Machine cycles are I/O read and I/O write, and machine cycles are memory read and memory write. The execution speed is 10 T state, the execution speed is 13 T state. It requires less hardware, it requires more hardware. That was all for this particular video, and for any queries, comment below, and please subscribe to our channel for more videos.